So this is our insert from our book, and our T table for our T distribution is actually right after the Z chart. Okay, the table F. So on the top, along the top over here, it's going to give you what kind of confidence level you can have. All right, so these are your confidence levels. So you can have 80%, 90, 95, 98, 99. You can do more, you can have different confidence levels and actually use technology for this, but we're going to stick to that. Now, at the bottom of the, below this, we have either one-tail distribution or two-tail distribution, okay? Two-tail distributions is when you're going to have both sides, and on the bottom of this chart, right over here, it explains what is a one-tail and what is a two-tail. Up until now, every time we looked at this alpha over 2 or the double-tailed one. Okay, the next important thing for us to select is the number of degrees of freedom. This degrees of freedom, okay, the DF over here says that it's going to be always one less than the number of items that you sampled. If you have sampled 10 items, then your degrees of freedom is going to be 9. Okay, if you have sampled 20 items, then your degrees freedom is going to be 1 less. It's going to be 20 minus 1, which is 19. Now, if you'll notice, after some of these numbers, they start skipping around, sort of. So you go from 38, you go to 40. From 40, you go to 45, and so forth. Your book wants you to be, sometimes we round to the closest one, but your book wants you to take the conservative approach. And that means don't give the sample the freedom it doesn't have, okay? So if you had 30, let's say, if you had 64 items in your sample, they don't want you to use 65, even though 65 is very close, but your 64 sample would not reach that many degrees of freedom. So you're better off sticking with what it did reach. It can have 60 degrees of freedom. It can't have 65 degrees of freedom. So for an n equals 64, you're actually going to go with this row, okay, and use that row. Now, it is very important to also say that once you found this item, okay, once you found your T value, that T value is for both left and right. It's going to be the same thing, okay? And I'll remind you that in our, when we calculated our Z confidence intervals, we took our point estimate and then we added or subtracted this critical value Z, okay? And then we have multiplied it by the standard deviation of the sample, okay? The standard deviation of the sampling distribution. When you're going to do a T distribution, you're essentially going to do the same thing, just since you do not know the sigma, you are going to substitute your sigma, for your standard deviation of your sample. So you're going to take your X bar plus minus that critical value T that you find from a table, okay? And then instead of sigma, you are going to use your S. And then the rest of this is all going to be the same, okay? So your left and your right T value, your critical T value, is going to be actually the same value. Again, T distribution is as symmetric as the Z distribution or the normal distribution, okay? And this is going to be our new formula that we are going to be using today. And let's go through a couple of examples and see how that is implemented in action.